Hello and welcome to another dSPACE Innovation Coffee Break. My name is Alexander Trapp and I am a product manager for the dSPACE Automotive Radar Test System DARTS. In this video I will show you how the resolution of a radar can be validated much more simple, reliable and repeatable than it was previously possible. I will go into why this is so important, why it is a challenge and how we can solve this. And then of course I will also demonstrate the solution. The resolution is what separates the conventional automotive radar from the imaging radar. In recent years, a lot of effort has been put into improving it. One example is the development of radars with higher bandwidth to enable a better distance resolution, or the development of more sophisticated antenna arrays with more channels or advanced super-resolution algorithms to improve angular resolution. But after all these development efforts, it is of course important to test the results. And to validate this improved resolution, you need to perform radar separation tests. With these tests, you can see at which point the radar under test can resolve two very close targets and where the separation breaks down and only one target is visible to the radar. And that is then the resolution. However, these tests are quite difficult to realize. You need two simulated targets that are fully independent from each other and can be controlled in range, speed and angle relative to the radar. For thorough validation, the separation capability needs to be tested over the whole field of view of the radar, from minimum range to maximum range and from the edges of the field of view to 0 degree. And since there is a lot of ground to cover, you need to be able to automate the movement of the two simulated targets in a reliable and repeatable manner. This has been a challenge because testing the different resolutions takes different setups. Range separation needs two targets to be simulated from exactly the same angle, and angular separation tests, of course, need their targets from two different angles. It is important to be strict with keeping all the parameters that are not resolution tested the same, because otherwise these differences will make it easier for the radar to separate the targets and you may overestimate your resolution. Realizing these setups was either costly or complicated because it involved manually changing the setup, like exchanging the cabling. With the new DARTS 9040 GT, this is not a challenge anymore. The system is a radar target simulator that can simulate two targets for the whole 5 GHz of the automotive E-band simultaneously. And it can simulate these targets either together from one front end or separated from two distinct front ends. All it takes to switch configuration is pressing a button or sending a command. And it offers all of this while staying more cost-effective than two separate radar target simulators. As a demonstration, I have set up a basic system for radar separation testing. It consists of the radar under test on one side. This is an automotive digital imaging radar from Unda, and the DARTS 9040 GT with its two front ends on the other side. The DARTS is currently set up to simulate one target with each of these front ends to allow angular separation testing. And if we look at the detections that the radar is perceiving, we can find the two simulated targets here. They are detected at the same range and the same Doppler velocity, but at different angles. If I now move the front ends together, the angle difference between the simulated targets also decreases. And at one point, one of the targets vanishes and only one remains. This means we have reached the resolution limit of our radar under test. In the lab, this simple test then will be repeated for a lot of different test parameters and settings in the radar to thoroughly validate its functions. But of course, this is not the only test. We are also interested in the speed and range resolution of our radar sensor. And for this now, we would have a problem with the setup. We can move the front ends very close together, but there will always be a remaining angle between the targets. If I change the Doppler of one target to make it easier for the radar to to separate them, like this, this angle can be clearly seen. This angle difference can be made smaller by changing the geometry of the setup, but it will always be better to just simulate the two targets from one and the same front end and completely eliminate this potential source of error. So let's just do this. I can easily change the system configuration in the DARTS web interface, just like this. And now I'm able to simulate the two targets of the DARTS with only one of the front ends. And if we go back to what the radar is currently detecting, there are now two simulated targets with exactly the same angle and Doppler speed, but different ranges. Now I can perform a range separation test by steadily decreasing the distance between the targets. Again, I can see at which range difference both detections become one, and with that I found the range resolution limit. I hope this short example on how our DARTS systems can make radar testing more efficient and reliable caught your interest. If you would like to see more other videos that go into different radar test cases, like scenario-based testing of autonomous driving systems or even vital sign detection, are available just next to this video. Of course, you can also get more information on our website or by simply getting in touch with us. Have a nice day and thanks for watching.
dSPACE, your partner in simulation and validation.